Dear friends, Namaste all. In this video, let us try to understand what is a flexible payment and a rigid payment. There are two types of popular road surfaces that we usually come across. One is a flexible payment and a rigid payment. Uh, Prior to understand the differences between the flexible payment and rigid payment, let us try to explore one of the mechanical um, property of material, namely flexural strength. Here you can see a member just as a beam being supported by two kinds of supports. Resting on this beam is resting on two supports. A load is acting in the transverse direction, that is perpendicular to the length of the beam. Actually, an axis that is passing through the center of gravity of cross section along the length is called a longitudinal axis. And if the loads are acting perpendicular to the longitudinal axis, then we call such loads as transverse loads. The tendency of these transverse loads is to apply a moment called bending moment or flexural moment. And this bending moment or flexural moment will typically bend the member, and the resistance, the strength against this bending is what is known as a flexural strength. Now let us first talk about the flexible payments. It has why we have discussed this concept is because flexible payments have typically very less flexural strength, and the flexible payments um, in their structural action, the only structural action of the flexible payments takes place exactly under the load of a wheel. Typically, the flexible payments have four surfaces. If you take a cross section, namely soil subgrade, this is the bottommost by rich soil, and sub-base course on top of it, a base course, and one surface course or a wearing course. Now this top layer will take up the compressive strength and mechanical wear and tear. Let's see the typical cross section of flexible pavement and load transfer mechanism. You can see one sketch showing the cross-sectional view of a pavement, a subgrade, which is of rich soil, and base course, sub-base course, base course, and on top of it, a wearing course. Now, the other diagram is showing a wheel load, which is trying to cause a localized stress. Here, the load will transfer to the lower layers by the action of particle to particle contact and distribution of the load. And the best example of flexible pavement is the bitumen pavement. Bitumen is nothing but a petroleum crude. It is obtained after the fractional distillation of a petroleum crude, and this particular material will act as a binder and is used as a wearing course or top course for a flexible for laying of a flexible pavement. Now, coming to the design principles, there are a lot of there are some empirical approaches and charts which are very handy in designing the flexible payments, such as one popular method is CBR method, California Bearing Ratio method, and group index method. Now, let us move on to this diagram is showing the laying of a flexible pavement. This black colored material, popularly known as road tar, is nothing but bitumen. Technically, it is bitumen. Now, coming to the rigid pavement, they have a very good flexural strength. Indeed, the concrete, it is made out of cement concrete. Cement will act as a binding material, and it may have a granular base or sub-base course. And the stresses here are not transferred from grain to grain, particle to particles, just as in the case of a flexible pavement. These particular payments, namely RCC payment, I mean cement concrete payment, sometimes reinforced steel can also be used for the design of rigid payment. And these payments, if they are well designed, they are very durable, meaning they are very long lasting. The life is more, unlike flexible payments, and they are quite economical too. Um, they are designed based on the principles from the elastic theory. This is a typical view showing the design of a execution of a rigid payment. Here, this view, this schematic view of a rigid payment, where a cross section is being shown. This is a top course bearing course or surface course is made out of cement concrete. You can see the pressure distribution here. There under the wheel, here under the wheel, the pavement is trying to deflect, just like a load acting on a beam, because they offer a lot of flexural resistance. So that's all. This is all about flexible and rigid pavements. Thank you.